now the test that I told you about the cations and anions with the help of the reagents NaOH and NH4OH. So we are going to perform those tests in the laboratory, and for that I have got here the salt of calcium. Here I have got calcium nitrate. Then I have also got the salt of ferrous ion, that is ferrous sulfate. Then I have got ferric chloride here for testing ferric ions. Then I have got salt of zinc for testing zinc ion. I have got a salt of copper sulfate for testing copper ion. And then I have got lead salt, that is lead nitrate, for testing lead ion. And I am going to test them with the help of these two reagents, that is NaOH. And then the second reagent that I am going to use is NH4OH. So first of all, what we are going to do, we are going to add these reagents in the limited quantity. So their precipitates of hydroxide will be formed, and then we will check the solubility in excess. So first of all, we are going to add NaOH or NH4OH in the limited quantity. A precipitate of hydroxide will be formed of a particular color, and then on adding these reagents in excess, we will see that these precipitates of hydroxide are becoming soluble or not. So let's start with that, and we are going to perform these tests. Okay, now first of all, I am going to take NaOH, and let's perform the test with the NaOH. Now for that I am going to take the salt of calcium. Now for saving our time, I have taken the aqueous solutions of these salts like calcium, ferrous, ferric, copper, zinc and lead here, and I will be testing one part of these reagents or the aqueous solutions with NaOH, and the other 6 aqueous salts of these ions with NH4OH. So first of all, I am going to take NaOH. Here I have got NaOH, and I am going to add this NaOH to all these salts, first in the limited quantity and then in excess. So I have taken NaOH, and this is the aqueous solution of calcium salt. So this you can see, on adding it dropwise, a milky white precipitate is forming in the test tube, inside the test tube. So this is what is going to happen when you are going to add it in the limited quantity. But when you are adding calcium in the excess, what will happen? Again, on adding NaOH in excess, the precipitate of calcium hydroxide will remain insoluble. So this is for calcium with NaOH. Now I am taking again the aqueous solution of ferrous. For that I have taken the aqueous solution of ferrous sulfate, and I am going to add NaOH first in the limited quantity and then in excess. So on adding NaOH, as you can see that a dirty green precipitate is forming at the bottom of the test tube, and if I add NaOH in excess also, then the precipitate of ferrous hydroxide that has been formed will remain insoluble. On shaking the test tube, the precipitate can be seen, and this precipitate is still insoluble in excess of NaOH also. So this is for ferrous. Now this is the aqueous solution of ferric chloride, and we are going to test for ferric ions with this solution. I am going to add NaOH firstly in small quantity, and you can see a reddish brown precipitate is settling down. Okay, and now I am going to add NaOH in excess so as to see about the solubility. Still, on adding NaOH in excess also, the precipitate has not become soluble. So this means the precipitate of calcium, the precipitate of calcium hydroxide, ferrous hydroxide and ferric hydroxide all were insoluble in excess of NaOH also. Now this is the solution of copper sulfate, and we are going to test for copper ions. See, on adding this NaOH in small quantity, pale blue precipitate is forming. Pale blue precipitate of copper hydroxide is forming. And this pale blue precipitate will remain insoluble in excess of NaOH also. So this is going to confirm copper ions. Okay, so with the help of this we have confirmed the cations copper, because copper ions form precipitate of pale blue color with NaOH in limited quantity also and in excess also. So all these 4 ions, that is calcium, ferrous, ferric and copper, are going to form their hydroxides, which are for calcium white in color, for ferrous dirty green in color, for ferric it is reddish brown in color, and for copper it is pale blue in color. And all these hydroxides are still insoluble in excess of NaOH also. Now this is the salt of zinc. For that I have taken zinc salt, and I am going to test for zinc ion. So if you are going to add NaOH in limited quantity, so a gelatinous precipitate will be formed. Gelatinous means the precipitate will float. Okay, it will be gel-like. So as you can see, a gelatinous precipitate is forming of zinc hydroxide, and this gelatinous precipitate of zinc hydroxide will become soluble in excess of NaOH. So as you can see, when I am adding excess of NaOH, the solution is becoming colorless. Why it is becoming colorless? Because of the formation of sodium zincate. Okay, so sodium zincate is a soluble salt. So you can see that the white precipitate that had been formed has disappeared because of the formation of the soluble sodium zincate. Because zinc hydroxide that had formed earlier as a gelatinous precipitate has changed into sodium zincate, and now it has become soluble. The last one is that of lead. So I have taken a salt of lead nitrate, and I am going to test for lead ions. So on adding in limited quantity, as you can see, a chalky white precipitate is forming. A chalky white precipitate of lead hydroxide is forming. Okay, now if I am going to add NaOH in excess, then what happens? Let's see. Now I am going to add NaOH in excess, and let's see what happens. As you can see, the precipitate of lead hydroxide that has been formed, that was milky white, that was chalky white, sorry, has disappeared because of the formation of the soluble sodium plumbite. So this is what is going to happen when you are going to test for these cations like calcium, ferrous, ferric, copper, zinc and lead. So as you have seen that calcium is forming a milky white precipitate, insoluble in excess. Ferrous is forming a dirty green precipitate, insoluble in excess of NaOH. Ferric is forming a reddish brown precipitate of ferric hydroxide, which is also insoluble in excess. Copper forming a pale blue precipitate, again insoluble in excess. Zinc had formed a gelatinous white precipitate, but that precipitate had dissolved in excess of NaOH because of the formation of sodium zincate. And lead had formed a chalky white precipitate that also had disappeared because of the formation of sodium plumbite. So this is all about the test with NaOH. Now we are going to perform our test with NH4OH on the same salts. Now I am going to perform the same test for same ions, calcium, ferrous, ferric, copper, zinc and lead with the help of ammonium hydroxide. Now ammonium hydroxide is a weak base, as I have told you. So on adding ammonium hydroxide to calcium salt, you are not going to get any precipitate. As you can see, I have added ammonium hydroxide to calcium salt, and I am not getting any precipitate of calcium hydroxide because ammonium hydroxide is a weak base and it provides very low concentration of OH minus ions. So calcium ions are not going to get precipitated. So this is the first difference between the precipitates formed by NaOH and NH4OH. Now secondly, I am going to take ammonium hydroxide and I am going to add to the ferrous salt. Now for ferrous salt again, as you can see, a dirty green precipitate is forming on adding ammonium hydroxide in the limited quantity, and if I add it in excess also, this dirty green precipitate will remain insoluble. So this dirty green precipitate of ferrous hydroxide will remain insoluble in excess of ammonium hydroxide also. Then I am taking the salt of ferric ion. This salt of ferric ion on adding ammonium hydroxide will form a reddish brown precipitate. As you can see, the reddish brown precipitate is getting formed, and this reddish brown precipitate is of ferric hydroxide, and it will remain insoluble in excess of ammonium hydroxide also, as you can see here. Okay, now moving on further, now comes copper. Now this will make a difference. Why? Because the copper precipitate of copper there in case of NaOH was pale blue and was insoluble in excess. Now let's see what happens in case of NH4OH. So first of all, see, a pale blue precipitate is formed on adding NH4OH in limited quantity. But this precipitate will become soluble and will change to inky blue solution because of the formation of tetraamine copper second sulfate, which is a complex salt and which is a soluble salt. So as you can see, when I have added ammonium hydroxide in excess, this precipitate which was pale blue has turned into inky blue solution of soluble tetraamine copper second sulfate. Now coming to the salt of zinc, again zinc is also going to make a difference. Why? Let's see. So on adding it in limited quantity with the zinc, first of all, what we are going to get? We are going to get a gelatinous white precipitate. As you can see, a small gelatinous white precipitate is formed. The solution is turned milky, but this milkiness will disappear in excess of ammonium hydroxide. The solution will become completely soluble and the solution will become completely colorless. Now you can see that the precipitate is dissolving and it is becoming colorless, completely colorless. Now the last ions which we are going to test for are lead, and for that I have taken lead nitrate. So this is the precipitate, chalky white precipitate of lead nitrate that is forming on adding ammonium hydroxide, and this precipitate will remain insoluble in excess also. It will remain insoluble in excess of ammonium hydroxide. So let's revise all the things. So this was the precipitate of calcium. No precipitate of calcium is forming in case of calcium ion because of the low concentration of OH minus ions, because calcium requires high concentration of OH minus ions. Then it was for ferrous ions, which was forming dirty green precipitate and insoluble in excess. Ferric ions, reddish brown precipitate, insoluble in excess. Copper, pale blue precipitate and forms soluble inky blue solution because of the formation of tetraamine copper second sulfate. Zinc was forming the gelatinous precipitate, gelatinous white precipitate, which was again becoming soluble because of the formation of tetraamine zinc sulfate, and lead, which is chalky white and insoluble in excess. So these are the tests which we have performed for testing the cation. Now only one cation